Talk about today our global technology trend monitoring work, which is one of the key pillars of our activities at the Higher School of Economics, ISSEK, at our institute. So we will briefly look at actually how we make use of trend monitoring in our foresight work, and then what's the ways actually we use to look at emerging trends, weak signals, and then look at those wildcards, and some methodologies and approaches we use for this purpose. We use and we developed actually at home here, and then some conclusions and ideas for further development. This is a joint presentation actually with myself and then my colleague Pavel Bakhtin in here. Then it will be actually followed by another colleague of us who will give another complementary presentation on this topic. It will be Ilya Kuzminov, so he's the next speaker. So first of all, why we look at trends, why trends matter. So we look at trends to generate ideas and identify opportunities which may emerge in the future. We would like to understand those developments which are emerging, and we would like to actually spot those developments right before they emerge or reach to maximum effect somewhere in the future, so that we can take opportunities and avoid any kind of negative consequences they may create. To gain confidence, to generate a kind of solid foundation and awareness of the trends, so we will know that actually we are up to date and we are following the developments in the world, and we are aware of the challenges, we are aware of the opportunities which may arise again. To beat the competition by anticipating developments again, and then to give some lead time for action before things actually happen. Sometimes it's too late actually when things happen to take action, so we try to kind of understand these developments in advance, and we try to understand their possible impacts so that we can generate some courses of actions. And we also do these activities to see whether the trends we are talking about are real trends or they are just hypes. We see that there are a lot of hypes actually, there are a lot of people talking about things which emerge rapidly and then they disappear, so there's a boom and burst of development. So we try to distinguish real trends from these bursts, which are also very common. And again, trends are important to inform actually strategic goals and decisions, understand again emerging markets, emerging products and emerging technologies, so we can start actually doing some research towards those activities and then to obtain those technologies in the near future and to reach further markets at the national and international levels, and simply to get ready for the future. So monitoring trends actually has become one of the key activities of our foresight processes. So here is a brief summary of the foresight exercises which have been undertaken in Russia, mainly by the Higher School of Economics. So there was the Foresight 2025 activity, which was relatively narrow in scope. As we moved in time, we see that actually the breadth and depth of activities are actually growing and expanding, and at the same time we are advancing more in methodologies and tools we are using. So today we are facing different challenges. Today the world context is different than what it used to be 10, 15 years ago. So we define our scope and we customize our methodology according to the needs of today and the future we are looking into. So today's activities are mainly characterized by the socioeconomic development. So it's not only narrowly defined technological areas, so it is looking broader to see the bigger picture, if you like. And we try to explore some strategic trends, breakthroughs, and weak signals of future trends which may emerge, and those wildcards of unexpected developments, unexpected, shocking or surprising. So they are also important, and we try to develop some action plans for those also. And another new feature of the recent activities, mainly Science Technology Foresight 2040, is to forecast innovative products, technologies and markets, and then develop some scenarios based on those forecasts and see actually how things may evolve and what are the main junctions and forks in this development and what kind of different futures this may lead to and what sorts of alternative actions we should take if the future goes into different directions. And we try to use some more sophisticated tools with the integration of qualitative and quantitative methods. So our global trend monitoring process is then kind of an ongoing activity, and we try to run this activity regularly and then try to provide some input for our ongoing projects, where the Foresight 2040 project is being the main client of this activity. So there are three pillars of the activity as you see on the screen. So there's the trend spotting phase, and then we look at actually different sources like databases, like social media, and we also make use of other trend portals. We do some trend mining activities ourselves to identify our unique trends actually, which may be found elsewhere in different places. And we use some readily available tools like the Vantage Point developed by our colleagues in Georgia Tech in Atlanta, US. And then we also develop our own tools and algorithms in-house. And we will present actually what those algorithms and tools are. And there are some other supportive software that we make use of for these activities. We also collect some intelligence by the use of some surveys at the global and national levels, and then review of some of our internal sources. And then all these are actually reviewed, synthesized, and then finalized, if you like, in form of some trends, all this information, through the use of some expert panels, through further bibliometric analysis, and we use them actually for our foresight exercises, and we use them for purpose of some of our roadmaps. And we also share these trends with wider audience, both internally and externally. Trend letter is being one of our outputs, which is a short digest of emerging trends in certain areas. So there's some description of trends, there's the evolution pathway of these trends, effects, and then markets related to this sort of trends, and drivers behind these trends which give rise to this sort of trends, and further information about it. So we are now actually trying to make more use of quantitative tools and then try to integrate them also with our qualitative tools. So each method and approach has its own strengths, advantages, and disadvantages. So that's why we are trying to develop some toolbox which combine different methods. The reason that we are talking about quantitative methods more today is that there's dynamic nature of scientific domains, so the change is very fast, and the knowledge production continues all the time in the world with the continuous emergence of new concepts, inventions, knowledge, technologies, generation of some new markets and innovation all the time, which may come from different sources around the world on a 24-hour basis. An increasing amount of available information. There are thousands of papers and scientific publications published every day. There are patents registered every day, so we would like to understand actually where these technologies are evolving to. And there's a higher speed of socioeconomic and technological change. If you see, actually things are changing so rapidly at the economic, political, and technological sphere, so we want to remain up to date with those. And greater interdisciplinary research, and thus growing need for reducing the effort to obtain useful information. It is not humanistically possible to read 40,000 papers a day, but actually we can develop some tools and then some methods to analyze 1 million publications at once. So there are this sort of possibilities which are readily available or which we are developing ourselves. So we use this information to detect some key trends and construct some new hypotheses for future development. So having said that, now we will elaborate upon some of the tools and methods we are using. I will hand this over to my colleague Pavel Bakhtin, who will explain what tools we are using and what tools we are developing ourselves. Thank you.
Thank you very much, Ozcan. So as basically the documents and the sphere of science and technology are rapidly changing, so does our methodology. We try to enhance it as much as we can with the new tools and methods that we integrate inside our process. So in the following picture, you can see our methodology represented in 4 major layers. First layer is a data layer. It really relies on the research design that we have for a particular project. So we basically take into account different types of data that we can play with. First is the most common for studies of such type is structured data. So it's patent publication and other databases where we have enough information enough metadata to actually have an idea about not only key players, organizations, authors doing the research, but also for example, research categories that these studies are related to, the content of this research, so we can extract various phrases, terms, and concepts from this to do our study. The semi-structured data is a bit less convenient to use because, of course, there is no such amount of metadata to support us. And finally, unstructured data is the most difficult one when we basically try to work with big analytical or forecast reports containing a lot of valuable information. But it is represented in a full text, full of things that we should carefully filter and sort in order to get some results. So the next layer, once we gather the data and process them with our tools, the second layer we call cluster. And there are 2 general processes that we go through with our process of trend analysis. First one is co-occurrence network and cluster analysis. When we work with publications and patents, we extract different phrases, and then we try to see how they co-occur in abstracts in these documents over the time. So building such networks and then clustering these concepts allow us to understand the topics in a much greater detail. At this point, of course, the involvement of expert is very important, but this gives us an evidence without even an expert to help us understand how this research area is basically represented. What are the key issues, the hot issues in the area, and how they're connected to each other. The dynamic pattern analysis I will demonstrate in the following slides is looking into the dynamics of occurrences of these terms and concepts around publications and patents over the year. So these are 2 a bit different types of analysis, which on the trend layer would try to intersect and then use in order to identify our trends. Finally, once we have the representation of our trends, we want to interpret them. We want to know what to do with them later. So we call this layer a semantic layer. And we use some more sophisticated tools like subject, action, object analysis and the use of ontologies, for example, in order to interpret these results and basically make some judgments along with expert evaluation. So there are some examples of, for example, co-occurrence network and cluster analysis results. We witnessed that in different research areas, the type of concepts is different. So when we take more technology-oriented areas, for example, like energy sphere, we see a lot of technical concepts and some possible solutions that could form our trends. When we look at health-related, for example, research, like in this picture, we see that we come up with more of a problem-oriented concepts that help us to understand what are the key issues that researchers are working at the moment, trying to understand the symptoms, trying to understand how to solve these problems. So this stage is very important for us to identify such trends and then find the solutions for them in other sources. This is an example for photonics, where we see that the terms actually change. In the previous, we saw a lot of diseases, problems, and challenges. Here we see more of a product and technology-oriented terms. So once we cluster these terms together, we can see their dynamics over the time. With help of an expert, we can even try to call these clusters in the way that they would be called in the research area. The next thing, and this is very important for us, is dynamic pattern analysis. So understanding how the terms change over the time and trying to group terms that have similar behavior together in order to understand what is like highly increasing, highly developing trend, which terms are related to group that actually is falling down over the time. So once we do such kind of clustering, we can then intersect patterns and thematic clusters together to see how are the areas represented, how do they change, what are the most influential of them. So this example, as you see on the slide now, is a cross-cluster intersection analysis for photonics between the clusters that we identify in our co-occurrence analysis and dynamic patterns. So we see different topics, different huge topics, and what is the distribution of these dynamic patterns within them. Where are more emerging trends that continue to rise, and where there are more stable developments over the time, which we see in this format. We basically integrate thousands and even more different terms and different data together to give a good visualization for further decision making. And this is more particular example in within the cluster, how these terms actually co-occur with terms that are related to emerging trends or early developments or declining developments. There can be different classification based on the data that we get. Another problem. So once we identify our problematic and problems and challenges, and identify the trends and some basic technological or product related solutions, we want to find some exact technologies and products that could be found in patents or some analytical reports. So we have the problems. How do we solve it? What are the particular kind of examples? So then we start to use a more sophisticated tool like semantic analysis using subject-action-object analysis in order to basically show how one product is developed. What are the parts of the product? What technologies does it use? In patents, using some sophisticated methods, we can basically achieve that. This is the diagram showing different terms and how they relate to other terms through some actions. So we can see that some products include various products. Some technology is a part of a bigger technology. So this gives us some interpretation. With the help of an expert, we can make a real judgment and then help experts to forecast the future. So to conclude this presentation, the quantitative trend analysis brings first of all, it brings the evidence for expert evaluation. So if we already kind of have a feeling about some trends, this kind of analysis can give us the judgment to say whether we're right or wrong. But it also helps us to explore some new trends and developments that we didn't hear about before or we don't understand. The analysis of publications allows us to determine key problems and challenges or some basic solutions to then move forward to understanding the trends. And with the trends, we move forward to understanding particular technologies and products, and then we can even build ontologies and understand how this research area is developing, what are the parts, and what are the most important objects. Our next stage of the development is, of course, exploiting the big data possibilities, big data full text mining, which is a much more complicated process, and our next colleague, Ilya Kuzminov, will be talking about it in particular. Thank you very much for your attention.